Hello there once again. Welcome back to our exam for review. This time we'll be doing problem 9. The question says that we have a temperature of the bowl of the soup that can be modeled by the equation y equals 72 plus 128 times e to the negative 0.046x, where y is going to be temperature and x is going to be the number of minutes the soup has been in the bowl. First we are asked for the initial temperature of the soup and the temperature of the room. Before we get into this, I want to talk to you a little bit about this equation, which is referred to as Newton's law of cooling sometimes. You'll usually see a number and then another number next to an E term. The number that's not next to E is the room temperature. And then the next number that is next to E is the temperature difference. What this is meant to model is the temperature of something hot that's been taken out of an oven and placed at a room of some kind. So if the room temperature is 172 and the temperature difference is 128, we can say the soup's starting temperature is going to be the 72 of the room plus the 128 that the temperature difference says, which gives us a total of 200 degrees Fahrenheit. That answers part A. Now part B asks for the room temperature. You can read that straight off the equation. It'll be right here, 72. Then in the E term, you'll have a number that is next to x. It tends to be negative, and that is called the cooling constant. If you take chemistry or physics, you might go a little bit more in depth on how to get this equation. For the purposes of Mat-171, most likely they'll give you the equation directly. So with part A and B answered, let's move on to part C. If you wait until the temperature of the soup is 160 degrees, how long will you be waiting? As we said earlier, y represents the temperature of the soup. They have told us it is 160, so what we'll do is we'll let y equal 160. And then it asks, how long will you be waiting? Remember that x represents the number of minutes the soup's been in the bowl, so that means we're going to try to find x. Now let's get a clean slide. Once again, we let y become 160, that's the temperature we want, equals 72 plus 128 e to the negative 0.046x. Now we're going to try to solve for the x. Before we do that, we need to first get the e term by itself. So we have a couple numbers in the way, the 72 and the 128, so let's first subtract 72 from both sides. 160 minus 72 gives 88. On the right, the 72's drop out, so we'll say 88 equals 128 times e to the 0.046x. Now we have to move the 128 to get the e by itself, so we will divide by 128. The 128 cancels out, and we have a fraction, 88 over 128 equals e to the negative 0.046x. Now our x is stuck in an exponent, and to remove it, we should use either log or ln. But since we have base e, means that ln is going to make our life easier. So we'll take ln on both sides. ln of 88 over 128 equals ln of e raised to the 0.046x with our negative sign here. Now remember that ln and e are inverse functions, so they both cancel out, and we'll get ln 88 over 128 equals negative 0.046x. Now that we're here, we're almost there. Just get x by itself. Now just divide by negative 0.046. We'll divide that on both sides. So our x is going to be ln of 88 over 128 divided by negative 0.046. Enter this into the calculator and you will get 8.15 minutes. And that's how long it will take for the temperature of the soup to drop from the 200 we started with down to the 160 we wanted. Thank you for watching. We'll see you again soon.